Hello and welcome. Today we're going to be talking about similarity and right triangle trigonometry. So for the agenda, we're going to go over some notes and then talk about some examples. So beginning with notes, what is a dilation? A dilation is a transformation that produces an image that is the same shape as the original but different size. So you can take a look at these two images here. Here we have a penguin. Here we have a smaller version of that penguin. This is a dilation. The same thing here. This figure is getting enlarged, and that's where we come with two definitions. Dilation to create larger image, that's an enlargement. Dilation to create a smaller image becomes a reduction. So here we have a reduction, here we have an enlargement. Okay, so here are some conventions and some notation. So the pre-image, that's the original figure, and this one is usually labeled as A, B, C, D, etc. The image, that's going to be the copy. This is the dilation and is labeled with the same letters followed by a prime symbol. So it's going to become A prime, B prime, C prime, D prime. Now, here are two disclaimers. If the scale factor is greater than 1, then the image is going to be an enlargement, so it's going to get bigger. If the scale factor is between 0 and 1, the image is going to become a reduction, so it's going to get a lot smaller. If we take a look at this diagram right here, we can see that this rectangle is A, B, C, D, and then this rectangle is A prime, B prime, C prime, D prime. So the ones that have the prime, those are going to be that's going to be the image. So we can say that A here. Let me outline it in red. A, B, D, C. All right, this guy right here, that's going to be the pre-image. So this is the pre-image right here. And this is the original. So we have a small figure here. And now the A prime, B prime, D prime, or whatever, C prime. Here, let me label it in orange. This is going to be the, whoa, this is still red. Here, let's do yellow. Whoa, you can't see that either. Well, let me use brown. So here, this part right here that I'm outlining, this one's going to be the image. Sorry, the image. That's our copy. So this is going to be the image. And without doing any math, we can use our common sense and notice that this figure is getting larger. So here we have an enlargement. So this is going to be an enlargement. Enlargement. All right. Okay, let's take a look at an example. So example 1, it says draw A prime, B prime, C prime after ABC has been dilated with the center at the origin. So this part is very important. So let me actually highlight this. So the center is at the origin and a scale factor of 1/3. So now in this class, we're only going to be looking at figures that are centered at the origin. And if your figure is centered at the origin, then I'll show you some strategies we can use in order to find the scale factor. But here, we can actually do it pretty easily. And for this problem, we're actually not trying to find the scale factor that's already given. We're just trying to dilate this figure. So let's begin by getting the coordinates of A, B, and C. So if we look at A, we see that the coordinate is, well, we have to start at the x-axis, and here we're at 0. And now we're going up 1, 2, 3. So the coordinate here is going to be 0, comma 3. And let's do that for B and C. So if we take a look at B now, in the x, we have to look at the x-axis first. So we're going to go 1, 2, 3. So we're at -3. So let's jot that down, -3. And now we're going to go down this time 1, 2, 3 units. Since we're going down, we have to write this as -3. So -3, -3, 0, +3. The last coordinate here, we're going to go 1, 2, 3 units to the right, and then 1 unit down. So here we have positive 3 and negative 1. Next, what we can do is, since we're given the scale factor, and let me underline that in green here, we have a scale factor of 1/3. So we're trying to scale this figure. Now I'm going to achieve that by scaling each coordinate. So each value is going to get multiplied by that scaling factor. So we have 1, 2, 3, 4, 5, 6 values that are going to get affected. And each one of these values is going to get multiplied by this 1/3. Now you can use Decimal's graphing calculator if you'd like, or you can just do this with your brain or your mental math skills. So 0 times 1/3, that's going to be 0. And here, let me write this down instead. It's going to look much cleaner. So here we have a prime, and a prime is now going to be 0 times 1/3 is 0, and 3 times 1/3 is 1. So a prime is 0, 1. Negative 3 times 1/3 is negative 1, and we're going to do that twice. So here b prime going to become negative 1, because negative 3 times 1/3 is negative 1, and then negative 1, because we have another negative 3. For c prime, 3 times 1/3, that's going to be positive 1 this time, because we have a positive 3, and negative 1 times 1/3 is negative 1/3. Oh, negative 1/3. All right, so just to show you pretty quickly how to use Decimal's graphing calculator, here you can just type in the 3 times the 1/3, and you see that you're going to get 1. The same thing here, negative 3 times 1/3, you're going to get negative 1. So let me just demo how to type this in. So here I have my keyboard. So again, your keyboard is right there. Or you can just use your computer keyboard. You don't necessarily have to open this. But here I'm going to write 3, and then I'm going to write parentheses, and I'm going to write 1 division symbol, and then I'm going to write 3. Now I'm going to click this arrow on the right to get out of this denominator and close it again with parentheses. And you see I have that multiplication of positive 1. And you can do a lot of things. So for example, let's say you were trying to do 7, and then you're trying to multiply it. So parentheses times, let's say 5/2. So you would get 5, division symbol, 2, right arrow to get out of the denominator, close it again with parentheses, and you can see that 7 multiplied by 5/2 is 17.5. So that's just a quick demo on how to use Decimal's graphing calculator to multiply with fractions. So let me get out. Okay, so now in order to complete this problem, we're going to have to graph this a prime, b prime, c prime. So let me choose red here. So a prime is going to be the coordinate for 0, 1, or 0, 1 is the coordinate for a prime. So here we go 0, and we go up 1, and we can draw this nice circle right here. Okay, so that's going to be a prime. So let me label this in red. Here I have a, and for some reason it's not getting colored in red. There we go. So we get a prime. That's this coordinate again, 0, 1. Let's go ahead and record negative 1, negative 1. So let me get my pen. So we're going to go to the left, negative 1, down, negative 1. And here we're going to draw this coordinate. That's going to be b prime. So let's label that as b prime. And now we have to get c prime. So we're going to go to the right 1, and then we're going to have to go down negative 1/3. Now here, it might be a very, very good idea to basically convert this into a decimal. So here the decimal approximation is going to make more sense, might make more sense to some of us. So here, if you use your Decimal's graphing calculator, you should be getting that this is approximately 0.33, about 30%. So here we're going to go to the right 1, and now we have to go down 0.33. So that's gonna be, we're gonna have to estimate. So maybe here's 50, so 0.33 might be somewhere around there. So let me go ahead and write that somewhere right around there. It's an approximation. So that's gonna be my C prime. So I have C prime, and then we're gonna connect the dots, and this is gonna be our reduction. So it should be getting smaller, and that's it. So try out the problems that follow, and then when we come back, I'll show you how to get that scaling factor.